Hey, this is Mr. Aiden. This is our last video for Unit 6. Integration and the accumulation of change. And this is definite integration by you. Substitution. If you really liked u-substitution, which is the coolest thing in calculus, is how we can figure out this reverse chain rule using u-substitution, then you'll really like definite integration. There is one little caveat that I have to teach you with definite integration, and it will be an integration celebration. And so here we go. We have this function. It's not a straightforward function, so we have to use u-substitution, but now it's a definite integral. It's not indefinite. We're going from a limit of 1 to 2. We're trying to take the area of this function from 1 to 2. So we're going to have to do u-substitution. So u is equal to x squared plus 1, which means du is equal to 2x dx. And boy, that works out great, doesn't it? Because I have 2x dx sitting right here, which means we're going to take the integral of our u value to the third power, and 2x dx is du. So we will be able to do this integration with respect to u. Now the difference, the caveat, is this function is being evaluated from 1 to 2, but these are x values, aren't they? And when we do our integration, our definite integration, we need these to be in terms of u, not x. And so we need to plug them into my original u equation. So u is equal to, the lower limit is 1, so 1 squared plus 1, which is equal to 2. So we're going from 2 to 2 squared plus 1, which is 5, from 2 to 5. And you might say, well, Mr. Aiden, we're not going from 1 to 2 anymore? No, we still going from 1 to 2 in terms of x values. In terms of u values, we're going from 2 to 5. And we have to do this u substitution. We have to evaluate everything in terms of u. So what's the integral of u to the third power is 1/4 u to the fourth power. And we are evaluating that from 2 to 5, which means first we're going to plug in our 5 value. Then we're going to plug in our 2 value to evaluate this function. So 5 to the fourth power is 625. Divided by 4 is 625 divided by 4. Minus 2 to the fourth power, which is 16 divided by 4, which is 4. When I get common denominators, I would end up getting 609 over 4. 609 fourths is my area under this original graph's curve. And so that is using definite integration by u substitution. So sometimes the AP likes to do questions like this, where Ella was asked to find this value, and this is her work. And we're just trying to find out where did she maybe make a mistake, if any. And so you can see, we're going to let u be x squared plus x. I like that. That's a really good thing that she did first. Then we're going to take the derivative. The derivative of u is 2x plus 1 dx. That works out as well. Great step 1, great step 2. Now we're going to plug in our values into our u substitution. So you can see the 2x plus 1 is dx. The 2x plus 1 dx is going to be du. She did that. She let u be this function right there, u to the third power. She did that. And she's going from 1 to 5. What is the problem with that? Is we're not going from 1 to 5. You can see our u values have to be in terms of u values. We're going to be 1 squared plus 1, which is 2. That should be 2. And u equals 5 squared plus 5. That is 30. This should be 30. That step 3 was where she messed up, isn't it? She did a good job with her integration of u cubed. It was 1/4 u to the fourth power, but her evaluation was wrong because those needed to be substituted. So step 3 was where Ella made a mistake, yo. So let's go through one more example of u substitution, definite integration by u substitution. What's going to be our integral? Or sorry, what's going to be our u? Our u is going to be x cubed minus 7. Again, I like to always do this to the side for u substitution, which means du is equal to 3x squared dx. 3x squared dx. Well, if you can see, I do have a 3x squared dx if u bring out a 5. If you put a 5 out here, you would get 3x squared dx x cubed minus 7 to the 4th power. So I have 3x dx, don't I? That is equal to du. I have this value, x cubed minus 7, which is u to the 4th power, if there's a 5 out front. If there's a 5 out front. Now I have to do my limits of integration, don't I? So we're going from 1 to 2. So I'm going to plug that in. U equals 1 cubed minus 7. That's negative 6. U equals 2 cubed minus 7. That's 8 minus 7. That's 1. So we're going from negative 6 to 1. Negative 6 to 1. And now I can do my integration. So that u is going up to the 5th power, dividing by 5. So 5 divided by 5, that's 1. And we're going from negative 6 to 1. From negative 6 to 1. So let's put in our 1 first. 1 to the 5th power minus negative 6 to the 5th power. So we have 1 to the 5th, which is 1. We have negative 6 to the 5th power, which is, so we have 1 minus negative 7776. So we end up getting 7777 for our area of this curve using u substitution. Again, you find your u, find your du, do your substitution there. Change your limits of integration in terms of u, then just evaluate. Do your integral and evaluate. And that is u substitution. The last video of this unit, definite integration by u substitution.